So we're looking now at another buffer problem, and this time we're looking for the moles of AH after the addition of HCl. So the first thing we'll do is get the initial moles. And the initial moles will look like this. So we're going to do moles of AH. Now we don't really need the moles of A-. I'm going to go ahead and get them anyway, but we don't need to actually have them for this specific problem, but you will need them for other problems. So that would be times 0.3302 liters. That's the milliliter up here if it's been converted into liters. That's going to be 0.232 moles. Do the moles of A-, that's going to be 0.796 moles per liter times 0.3302 liters, and that's going to be 0.263 moles. Okay. Next we do the moles of H+, that comes from the HCl, and that's going to be 0.297 moles per liter, and that's times the volume, which is 0.01670 liters, and that's 0.00496 moles. Now in this instance, what we're doing is we're adding H+ into the solution. It will react with the A- and turn it into AH. So what's going to happen is that the new moles of AH here, I'll put new here, will be the initial moles of AH plus the moles of H+. And that's going to be 0.232 moles. Oops. Plus 0.00496 moles. And that's going to come out to be 0.237 moles. Alright, let me justify that, and we'll draw a diagram up here. So initially, if you have A-, AH, and AH, kind of like what we have, equal amounts of A- and AH in the solution, and you add H+ to it, what's going to happen is that the A- will react with the H+ and turn into AH. The A- goes down, but the AH goes up. So that'll become A-, AH, and AH. So you can see the AH goes up, and that's why we're adding down here.